Is the universe fundamentally stable,
Hmm?
or could the very fabric of empty space, the seemingly harmless vacuum all around you, just suddenly collapse in on itself?
And destroy literally everything we know.
Right.
Yeah.
Destroy everything. It is a completely mind-bending question, isn't it? You go about your day, and you just take for granted that the empty space between the atoms in your body and the space between the stars is just this permanent fixture of reality.
A safe, static background.
Exactly, a static background. But in the world of theoretical physics, people have been debating this idea of a vacuum implosion for decades now.
Yeah, the false vacuum decay.
Right. This terrifying concept that empty space might actually be a metatestable state. Like it's acting like a tightly compressed spring just waiting for the right localized trigger to violently snap.
And release a catastrophic amount of energy.
Rewriting the laws of physics at the speed of light. It's intense. Okay, let's unpack this because today we are going on a journey that completely dismantles that fear. We are going to rewrite exactly how you should look at the concept of nothingness.
It's a very reassuring deep dive today.
It really is. For this deep dive, we have an incredibly dense stack of highly theoretical sources. We're looking at a series of scientific excerpts, a deeply detailed mathematical briefing document, and this really complex topological infographic.
Very complex.
Yeah. And they are all focused on a singular, completely mind-expanding topic: spectral gap bifurcation and the limits of vacuum cavitation. So the mission for today's deep dives is to take you from the tangible macroscopic physics of collapsing fluid voids all the way down to the absolute pre-ontological foundations of reality.
Down to the absolute basement of existence.
Right, to figure out if our universe is actually structurally sound.
What's fascinating here is that to definitively answer the question of vacuum stability, these sources completely bypass the standard arguments of quantum field theory.
Or they totally ignore them.
Yeah. We are not just going to look at the Higgs potential or
Yeah.
the mass of the top quark, which is, where the traditional false vacuum debate usually lives.
Right, the usual suspects.
Yeah, exactly. Instead, the authors construct a specialized four-layer ontological framework to analyze the fundamental nature of physical manifestation itself. It is a highly rigorous approach, and it culminates in a definitive pre-closure no-go theorem.
A no-go theorem, meaning it mathematically just cannot happen.
Precisely. We are going to examine the classical mechanics of fluid cavitation, the actual real-world physics of imploding bubbles, and use it as a structural metaphor to understand quantum field dynamics.
Which is wild to think about, bubbles in water explaining the universe.
It really is. We'll look at where that classical metaphor completely breaks down due to a severe mechanistic mismatch. And then we'll traverse the author's proposed ontology, moving from pure abstract invariance all the way down into the discrete matter we actually interact with.
We're going to have to get into the tensor mathematics of the spectral gap too, right?
Oh, definitely. The spectral gap, the nature of a pitchfork bifurcation in the fabric of reality, and ultimately demonstrate why the universe's baseline is globally invariant. It is strictly incapable of the kind of collapse that popular science often fears.
Yeah, it is a very mathematically demanding framework, but its implications for the stability of reality are incredibly profound.
And change everything.
So I am really looking forward to digging into the math, but I think to properly ground this, we should start with the macroscopic phenomena the sources use as their primary structural metaphor.
Start with the familiar.
Right. I want you to imagine holding a magnifying glass to the absolute emptiest part of deep space. You're trying to figure out if it can cave in on itself. But to understand the author's argument about the limits of that vacuum, we first have to understand classical fluid cavitation.
Which is something we see in the real world all the time.
Exactly. A submarine propeller tearing through the water, or the intense pressure wave from a pistol shrimp's claw snapping shut.
Purely mechanical process.
Purely mechanical.
Yep.
But the briefing document spends a massive amount of time breaking down the thermodynamics and fluid dynamics of this before it even touches quantum mechanics. So how exactly do the sources mathematically define this classical cavitation process?
So, the documents describe classical cavitation as a highly nonlinear, dynamic response to severe localized pressure gradients, specifically within a compressible medium.
Okay, compressible medium, like water.
Right. It initiates when the local dynamic pressure of a fluid falls below its vapor pressure at a given temperature.
So the pressure just bottoms out.
Exactly. And when that happens, the fluid medium structurally fails. It literally tears apart, forming a void or a cavity filled with vapor.
And the document is very clear that this isn't like boiling, right?
No, not at all. This isn't a thermal phase transition like boiling a pot of water over a flame where you're injecting thermal energy to break molecular bonds. This is a purely mechanical yield point. You are ripping the water apart with force.
Right.
The interior of this newly formed cavity possesses a drastically lower mass density than the bulk fluid surrounding it.
It's basically empty compared to the water outside?
Yes. And the critical phase begins when the external pressure of the surrounding fluid recovers. Or, when the cavity is swept into a region of higher ambient pressure.
So the void gets pushed into higher pressure water.
Exactly. This establishes an extreme, inward-pointing radial pressure gradient. The surrounding bulk fluid is subjected to a massive restorative force, driving it to violently collapse the cavity.
And the surrounding liquid rushing inward doesn't just casually fill the space, like it's not a gentle wave. The document specifically highlights Rayleigh-Plesset dynamics.
Yes, the Rayleigh-Plesset equation.
Right. I know the Rayleigh-Plesset equation models the behavior of a spherical bubble in an infinite body of liquid. But how does it account for the sheer violence of this collapse? Because, the velocities we were talking about here as the bubble shrinks are just staggering.
They are. And the violence is entirely due to the geometry of the collapse.
Yeah.
Which the Rayleigh-Plesset equation captures perfectly through its inertial terms.
Okay, break that down for me.
Think about it. As the fluid wall rushes inward, the surface area of the cavity is shrinking exponentially.
Right. Oh, yeah, the sphere is getting smaller.
Exactly. This means the mass of the fluid rushing in is being forced into an ever-decreasing volume. The kinetic energy of that fluid shell must be conserved. And because the volume is collapsing, the inward velocity of the fluid wall has to accelerate drastically.
It's like a figure skater pulling their arms in to spin faster, but on a catastrophic scale.
That's a great analogy.
Mm-hmm.
The mathematics model this as the radius, r, approaching zero. As r approaches zero, the nonlinear inertial terms in the differential equation completely dominate,
causing the velocity to spike.
The velocity and the internal pressure of the vapor trapped inside the bubble spike to extraordinary values. We see extreme adiabatic compression.
Adiabatic meaning it happens so fast it can't exchange heat.
Precisely. The interior gas is compressed so rapidly that it has absolutely no time to exchange heat with the surrounding liquid. This adiabatic heating generates localized temperatures that can reach tens of thousands of Kelvin.
Tens of thousands? That's hotter than the surface of the sun.
It is. It often leads to actual plasma formation and the emission of broad-spectrum electromagnetic radiation.
Which is what we observe as sonoluminescence.
Exactly. Light created from sound and pressure.
Sonoluminescence is just one of those phenomena that feels like it breaks the rules of physics until you look at the math. A bubble of vapor in room temperature water collapsing so ferociously that the inside briefly reaches solar temperatures, emitting a physical flash of light.
It's incredible.
But the briefing document draws a very hard line here regarding the thermodynamics of this event. It makes a strict clarification about where this energy comes from. And that seems crucial for the quantum arguments later on.
Oh, that clarification is paramount.
Yeah.
The authors are incredibly precise in stating that cavitation does not create new energy.
Right. It's not a magic energy generator.
Not at all. It is entirely a process of geometric energy concentration. The immense heat, the shock waves, the sonoluminescence, all of these are simply the manifestation of mechanical energy that was already present in the pressure field of the bulk fluid.
It's just being squeezed.
Exactly. It's now hyper-concentrated into a microscopic spatial volume. And this mechanism is entirely dependent on the classical properties of the medium itself.
So the medium has to have specific traits for this to work.
Yes. For Rayleigh-Plesset dynamics to occur, the medium must possess a classical mass density, denoted as rho. It must exhibit surface tension, sigma, to actually define a distinct interface between the liquid and the vapor.
To even have a boundary in the first place.
Right. And it must have a well-defined equation of state that includes vapor pressure and a finite speed of sound. Without these macroscopic classical properties, the inertial collapse described by the equation cannot physically manifest.
So the concentration of energy absolutely requires a compressible medium with inertia.
Exactly.
Okay, so we have this inward rushing wall of fluid concentrating kinetic energy into a microscopic point. But fluid dynamics are inherently messy, right? Perfect spheres rarely exist in nature for long.
Very rarely.
So to analyze the stability of this collapse, the sources rely heavily on a mathematical decomposition tool, spherical harmonics. I see how they use it to classify the boundary deformations of the collapsing bubble. but I want to make sure we understand why they emphasize specific modes over others.
Of course. So spherical harmonics, denoted mathematically as while m, are orthogonal functions defined on the surface of a sphere.
So they measure the shape of the bubble.
Essentially, yes. They are the standard mathematical language for analyzing angular momentum and boundary perturbations in three-dimensional space. In the context of a collapsing cavity, they allow us to separate the geometry of the collapse into distinct modes.
Okay, and the fundamental mode is what? The L equals 0 mode.
Yes, the L equals 0 mode. This is the purely radial isotropic monopole mode.
Meaning it's a perfect sphere.
Exactly. If a collapse is dominated entirely by the L equals 0 mode, the cavity remains perfectly spherical as it shrinks. The pressure gradient is completely uniform from all directions, and all the kinetic energy is focused perfectly into the geometric center.
And that's how you get the crazy heat and light.
Right. This isotropic symmetry is the strict prerequisite for achieving the extreme energy densities required for phenomena like sonoluminescence. It is the most efficient, violent manifestation of the collapse.
But the higher L modes, the dipole, quadrupole, and beyond these, represent the breakdown of that perfect symmetry, right? Like if a bubble is near a solid wall, say a submarine propeller, the pressure field isn't uniform anymore.
Exactly the case. The higher L modes quantify shape instabilities. They describe the perturbations, the surface rippling, and the asymmetric deformations of the cavity boundary.
So the perfect sphere gets interrupted.
Yes. When these higher L modes become unstable and grow faster than the fundamental L equals 0 radial collapse, the symmetry is broken. The kinetic energy is no longer focused into a single central singularity.
Where does it go then?
The instability often manifests as a reentrant microjet.
A microjet.
Yeah. One side of the bubble wall accelerates faster than the opposite side. It literally pierces through the center of the cavity and strikes the far wall at supersonic velocities,
Whoa.
generating severe localized shock waves. This is actually the mechanism responsible for the physical pitting and erosion of solid marine propellers.
That is wild. The water punches a hole in solid steel because of a microjet.
Exactly. So the spherical harmonics simply provide the orthogonal basis to mathematically track this, to see whether the system favors a symmetric, centralized energy concentration or an asymmetric, distributed energy dissipation.
I want to hold on to that distinction between the purely symmetric L equals 0 mode and the chaotic higher L modes. Because reading ahead in the briefing document, that mathematical distinction seems to be the exact bridge the authors use to connect macroscopic fluids to the fabric of reality itself.
It is a crucial link.
So we've established the metaphor. We know the thermodynamic and geometric requirements for physical water to cavitate. So to apply this to the vacuum of space, we have to look at the infographic's primary argument, the mechanistic mismatch.
Right.
If we are treating empty space as the medium, why does standard physics reject the idea that a localized drop in energy could tear a cavity in the vacuum, forcing the universe to rush in and implode?
Well, the mechanistic mismatch arises because the quantum vacuum, as defined by standard quantum field theory, shares absolutely no ontological properties with a classical fluid.
None at all?
Zero. The standard model defines the vacuum as the lowest possible energy state of a system of quantized fields. It is the state where the expectation values of all particle number operators are simply zero.
So when we attempt to map the parameters of classical cavitation onto the quantum vacuum,
The mapping fails fundamentally. A fluid is a state of condensed matter with mass density and internal cohesive forces like surface tension. A quantum vacuum possesses neither of those things.
right, it's not a fluid, it has no density.
Exactly. And the driver for fluid cavitation is a localized macroscopic pressure deficit. But in QFT, the theoretical driver for a vacuum instability is entirely different.
How so?
It involves a scalar field, typically the Higgs field, theoretically tunneling through a metastable potential energy barrier into a lower, quote-unquote, true vacuum state.
So it's quantum tunneling, not a mechanical crunch.
Exactly. This is a quantum mechanical phase transition modeled via instanton solutions in Euclidean spacetime. It is not a classical fluid wall driven by a mechanical pressure gradient. The drivers, the medium, and the mathematical mechanisms are completely orthogonal to one another.
Here's where it gets really interesting. Even if we completely ignore the fact that the vacuum isn't water and we just look at the raw energetics required to significantly perturb the structured fields of the quantum vacuum, the sources introduce what they call the energy scale abyss.
The abyss, yes.
The numbers here are just, they defy any intuitive grasp.
They really do. The energy scale abyss is a quantitative demonstration of our observational limits regarding vacuum dynamics. The authors calculate the absolute minimum energy density required to induce a measurable, non-perturbative restructuring of the local vacuum state.
And what are those numbers?
They point to the quantum chromodynamics scale, the QCD scale, which governs the strong nuclear force. That demands energy densities on the order of 10 to the 35th joules per cubic meter.
10 to the 35th.
Yes. And to probe the electroweak symmetry breaking scale, you were looking at densities around 10 to the 45th joules per cubic meter. These aren't just large numbers. They represent energy concentrations that are fundamentally inaccessible to our current epoch of the universe.
Right. To contextualize 10 to the 45th joules per cubic meter for you listening right now, a large-scale thermonuclear weapon releases total energy in the realm of 10 to the 14th or maybe 10 to the 15th joules.
A literal drop in the ocean.
Yes. A drop in the ocean. The briefing document analyzes our most advanced technologies like petawatt-class lasers generating extreme electromagnetic fields or heavy ion colliders, and points out that even at the microscopic intersection of these beams, we are 20 to 30 orders of magnitude too weak.
We are nowhere close.
We literally do not possess the capacity to scratch the surface of the vacuum.
And that technological inability to perturb the vacuum is compelling. But the authors fortify this point with an empirical astrophysical argument, which they term the global stability argument or the cosmic stress test.
Oh, I love the cosmic stress test.
Very logical. If the quantum vacuum were truly a metasustible state, a false vacuum prone to decay upon sufficient localized energetic triggering, we just have to consider the history of the cosmos.
The universe is an incredibly violent environment.
It's extremely violent. For 13.8 billion years, it has operated natural particle accelerators that absolutely dwarfs any theoretical human engineering.
We are talking about ultra-high energy cosmic rays, right? UHCCRs.
Yeah.
These are protons traveling so close to the speed of light that a single subatomic particle carries the kinetic energy of a brutally fast fastball. When these particles slam into the interstellar medium or into the atmosphere of a planet, the localized center of mass collision energies are astronomical.
Precisely those. Furthermore, we must account for the cataclysmic macroscopic events. Hypernovae, the collapse of supermassive black holes, and binary neutron-star mergers.
Neutron-star mergers are terrifying.
They are. A neutron-star merger concentrates several solar masses into a volume the size of a city. It's spinning at a fraction of the speed of light, generating magnetic fields billions of times stronger than anything on Earth, and literally ripping the very metric of space-time into gravitational waves.
So the argument is, if the vacuum was fragile, one of these events would have broken it by now.
Exactly. If the localized energy density required to overcome a metastable vacuum barrier could be reached, these cosmic environments would have undoubtedly breached it long ago.
And since we're still here,
the fact that the universe has not undergone a catastrophic vacuum phase transition, that the speed of light bubble of true vacuum has not erased our observable cosmos, serves as empirical historical proof.
Proof of what, exactly?
That the current vacuum state is globally minimal. There is simply no deeper potential energy well for the universe to fall into.
So observationally and historically, we are safe. We can sleep at night.
Absolutely safe.
But the sources don't stop at just observational proof. To truly prove why the vacuum cannot collapse, they abandon the standard QFT model entirely and introduce their own foundational architecture. And this is where we shift from standard physics into some incredibly dense theoretical territory.
This is the core of their entire thesis.
The sources propose a specialized four-layer ontological framework. They argue that to really understand the limits of reality, we have to map out a hierarchy of existence, starting from pure abstract potential and stepping all the way down into the physical matter we touch.
Right. The authors argue that standard physics fails to adequately describe vacuum stability because it treats the vacuum as a physical, albeit empty arena.
Like a stage waiting for actors.
Yes, but the four-layer ontology attempts to correct this by defining reality as a gradient of manifestation, moving from absolute invariance down to discrete localization.
Let's walk down that ladder, layer one.
The foundational layer, layer one, is termed Omnilectic invariance, or OI.
Omnilectic invariance.
Yes. This is defined as the absolute invariant ground of being. It is characterized by pure, unbroken potential symmetry.
So no actual things exist yet.
Correct. In the state of OI, there is no spatial geometry, there's no temporal flow, no metric tensor, and absolutely no differentiation of states.
Total uniform.
Yes. Because there are no distinct states, there are no relational dynamics. It is the absolute pre-ontological condition.
It is the ultimate blank slate. If physics is the study of how different things interact with each other, omnilectic invariance is a realm where the concept of different things hasn't even been theorized yet.
Beautifully put.
So moving one step down this ladder, we arrive at layer 2, the coherence vacuum, or CV. Now, the briefing document is incredibly meticulous about differentiating this coherence vacuum from the quantum vacuum of the standard model we just discussed. How does the framework define the specific layer?
The distinction is vital here. The standard KFT vacuum is already populated with fluctuating fields. It has a defined spacetime metric and governed interactions.
That's busy.
It is. But the coherence vacuum in this ontology is defined as a pre-closure structured continuum.
Pre-closure, what does that signify?
The term pre-closure is the key. It signifies that reality at this layer has not yet locked into definitive, physically manifested value.
That's still just potential.
Exactly. The CV possesses mathematical structure and the absolute potential for energy definition, but it is devoid of any actual extractable physical energy or realized physical gradients.
So it has the rules, but no actual players on the field.
Right. It is the very first mathematical step away from the absolute symmetry of omnilectic invariance. It's minimally differentiated. It contains the mathematical rules for how fields might behave, but it lacks the actualized physical fields themselves.
Okay, so if omnilectic invariance is a blank piece of paper, the coherence vacuum is the blueprint drawn on it. It contains the exact mathematical relationships and structural potential for a building, but you can't live inside a blueprint.
You cannot. The blueprint itself exerts no physical force.
Right. Which brings us to the threshold where physics as we know it actually begins. Layer 3. Continuum ontology, or CO. The framework refers to this as partial closure.
Yes, continuum ontology marks the emergence of the physical universe. In this layer, the perfect symmetries of the coherence vacuum are partially constrained or broken.
Symmetry breaking. This is where stuff happens.
Exactly. This breaking of symmetry allows for the realization of relational structures. The mathematical potential of the CV condenses into actual continuous physical fields.
Like what kind of field?
Such as the electromagnetic tensor field, the gravitational metric field, and the various quantum wave functions. The critical development in the CO layer is that physical gradients become meaningful.
Gradients, so differences between point A and point B.
Yes. We now have a smooth, continuous spacetime where a point A can possess a different field potential than a point B. The dynamics of physics waves, interference, continuous flux, all operate within this continuum ontology.
But it's still waves, right? Not solid stuff yet.
Correct. It is still a reality of smooth, distributed waves, not solid objects.
Which necessitates the final step down the ontological ladder, layer 4, atomic ontology, or AO. The document describes this as full closure.
Full closure. The atomic ontology represents the highly localized, discrete reality that characterizes our macroscopic experience.
Stuff we touch and feel.
Exactly. The smooth, distributed fields of the continuum ontology undergo localized, nonlinear collapse events, condensing into discrete entities. Yes. This is the domain where properties like rest mass, discrete electrical charge, and quantized angular momentum or spin manifest permanently.
So it's the transition from waves to particles.
It is the transition from the probabilistic wave nature of the universe to the definitive particle nature of atoms, molecules, and macroscopic structures. The ontological ladder thus maps a generative trajectory.
From pure symmetry all the way down to a rock.
Right. From unbroken symmetry, OI, to structured potential, CV, to continuous physical fields, CO, and finally to discrete localized matter, AO.
Okay. Having mapped this trajectory, the authors use the specific architecture to address the core question of our deep dive. If the coherence vacuum, layer 2, is this vast reservoir of structural potential, is it physically possible for it to undergo an inward collapse, similar to the classical fluid cavitation we discussed earlier?
And the mathematical response to that is found in the absolute centerpiece of their analysis, the pre-closure no-go theorem.
The no-go theorem.
Right. The authors do not merely argue that a coherence vacuum collapse is unlikely. They provide a rigorous variational proof demonstrating that such an event is mathematically and ontologically forbidden.
Forbidden. Strong word.
It's accurate, though. The theorem dismantles the implosion hypothesis by analyzing the strict mathematical prerequisites for a localized collapse, and proving that the CB layer completely lacks the required topological and differential operators to make it happen.
Let's break down the components of that no-go theorem, then. The first major pillar of their mathematical proof relies on the concept that, in the coherence vacuum, all relational gradients are fundamentally gauge null.
Gauge null. Yes.
In standard continuum mechanics, a gradient is a driving force, right? A pressure gradient drives fluid flow. A thermal gradient drives heat transfer. So if the gradients in the CV are gauge null, how does that prevent dynamic movement?
Okay, so in differential geometry and gauge theory, a gradient represents a measurable variance of a field over a spatial or temporal metric. It defines a slope, a difference in potential that dictates the flow of energy or momentum.
Like a hill. Water flows down the hill because of the gradient.
Exactly. So when the theorem states that gradients in the CV are gauge null, it means that any theoretical mathematical gradients one might write down at this pre-closure layer do not parameterize distinct, measurable physical states.
Wait, meaning what exactly?
Because the CV is pre-physical and minimally differentiated, shifting from one coordinate to another along a hypothetical gradient results in absolutely no change in the physical state of the system.
Because everything is still potential.
Right. The slope is effectively zero everywhere. If all gradients evaluate to null, there is no potential difference. Without a potential difference, there is no force vector.
And without a force vector, nothing pushes inward.
Exactly. It is physically impossible to induce the inward radial acceleration required for an implosion.
It's like trying to measure the slope of a hill before the concepts of up or down have even been invented. There is literally no downhill for the energy to roll into.
That's a perfect way to visualize it. And the theorem couples this lack of gradients with a topological argument regarding the absence of boundary operators.
Boundary operators, because to have a bubble collapse, a cavity has to actually exist.
Right, and a cavity is defined by its boundary, the interface separating the inside from the outside.
Exactly. You need an inside and an outside.
Precisely the point that topology makes. The mathematics of cavitation require a distinct surface integral. You must be able to evaluate the pressure on the exterior of the boundary versus the interior.
But the CV doesn't have that.
No. The no-go theorem proves that within the maximally symmetric topology of the coherence vacuum, there exists no functional operator capable of distinguishing an interior spatial region from an exterior region.
Because it's a perfectly unbroken continuum.
Yes. The CV is a continuous, unbroken manifold of pure potential. There are no interfaces, no phase boundaries, and absolutely no domain walls.
So no bubbles?
If you cannot mathematically define a boundary, you cannot define a cavity.
Yeah.
And if there is no cavity, and there were no gradients to exert inward pressure on a non-existent boundary, the concept of implosion is rendered entirely meaningless.
It's not just unlikely, it's a mathematical absurdity. So what does this all mean for the vacuum itself?
It means the vacuum is not a highly pressurized system held back by a fragile barrier. It lacks the internal plumbing, the gradients, and the boundaries to support an inward destructive collapse.
Right. It just doesn't have the architecture for it.
If we connect this to the bigger picture, it requires a complete paradigm shift in how we conceptualize foundational stability. The coherence vacuum is not a metastable false vacuum waiting to decay downward. It is the absolute neutral invariant baseline.
It's the floor.
It is the floor. Because it is the state of minimal differentiation, it cannot mathematically collapse into a state of even lesser differentiation.
Because the only thing lower is omnilectic invariance, which is just non-existence.
Exactly. There is no lower ontological state to fall into other than OI. Therefore, the pre-closure vacuum can only move in one direction ontologically. You can only differentiate.
You can only build up.
Yes.
Yeah.
You can only move upward into the higher, more complex layers of the continuum and atomic ontologies.
And here's where I want to push back a little. The universe is full of violent, localized, nonlinear collapse events.
Right.
Stars collapse, wave functions collapse, matter condenses. If the coherence vacuum is mathematically forbidden from being the source of this instability, where does the instability actually live in this framework?
That is a great question. The instability is entirely restricted to the derived regimes.
The higher layers.
Yes. Once the invariant potential of the CV differentiates and achieves partial closure into the continuum ontology layer 3, physical gradients, metric geometries, and field interactions emerge. Instability requires a structure.
You need stuff to have instability.
Exactly. It requires the existence of differentiated states that can interact, interfere, and seek lower local energy configurations. The mathematical description of instability only becomes valid in layer 3 and layer 4.
And to govern the stability of this layer 3 continuous reality, the briefing document introduces a highly complex mathematical object called the vacuum coherence tensor, or VCT.
The VCT. Yeah.
The authors apply a technique called canonical sectoring to the spectrum of this tensor, breaking it down into a one-direct sum, three-direct sum, eight-dimensional decomposition.
The 1, 3, 8 sectoring.
Right. And for any of you listening who are deeply familiar with group theory and quantum mechanics, those numbers 1, 3, and 8 immediately bring to mind the dimensional representations of the standard model gauge groups, U1, SU2, and SE3.
It's no coincidence.
I assumed not.
Right.
How does the framework assign physical meaning to these specific eigenvalue blocks within the continuum?
So the canonical sectoring the vacuum coherence tensor is the framework's method for quantifying the structural integrity of spacetime itself. They partition the spectrum of the tensor into 3 distinct eigenvalue blocks, which dictate the actual modes of physical manifestation.
Let's take them one by one. The first block.
The first block, B1, contains a single scalar eigenvalue, lambda 1. This represents the pure, unstructured scale of the continuum, the foundational volume metric.
Okay, just the baseline volume. And the second block.
The second block, B3, is a three-dimensional vector representation. This contains eigenvalues lambda 2, lambda 3, and lambda 4.
Okay.
The authors designate this the vector relational block. It governs the smooth, continuous, non-local relational structures of spacetime and quantum fields.
So this is the wave part of reality.
Exactly. This block ensures that the continuum ontology remains a smooth manifold where wave dynamics can propagate without immediate localized collapse.
Got it. And the final block, the big one, B8.
The third block, B8, is an 8-dimensional adjoint representation containing eigenvalues lambda 5 through lambda 12.
Lambda 5 to 12. Okay.
This is designated the adjoint or atomicizing block, and this spectrum represents the ontological drive toward discrete localization.
The drive to become solid particles.
Yes. It is the mathematical tendency of continuous fields to undergo symmetry breaking, localized condensation, and manifest as discrete point-like entities, the atomic ontology.
So the stability of our continuous reality, the fact that the electromagnetic field or the fabric of spacetime doesn't just spontaneously shatter into a shower of localized discrete particles everywhere all at once, depends entirely on keeping that smooth relational block, B3, isolated from the discrete atomicizing block, B8.
That isolation is absolutely critical.
And this isolation is quantified by the central mathematical parameter of this entire deep dive, the spectral gap, denoted as a G star.
The spectral gap is the critical stability parameter of the universe. It is formally defined as the algebraic difference between the lowest eigenvalue of the relational block and the highest eigenvalue of the atomicizing block.
So G star equals lambda 4 minus lambda 5.
Exactly. This gap acts as a structural rigidity metric for the continuum ontology. As long as this gap is strictly positive, meaning G star is greater than 0, the relational and atomicizing coherence bands remain cleanly separated.
They can't touch.
They cannot mix. The smooth, continuous modes of spacetime are energetically prohibited from mixing with the discrete, highly localized modes. The gap acts as an ontological barrier, preserving the wave nature of the continuum and preventing spontaneous, unprovoked collapse into localized matter.
I was reading through the section on the bifurcation dynamics, and I grasped the basic topological split, but how does the math model the specific transition when that barrier fails? Like, what actually happens to the continuum when this spectral gap G star is forced to approach 0?
Well, when external stress or extreme localized field interactions force the eigenvalues to shift, causing the gap to soften and close, meaning G star approaches 0, the framework defines this as a spectral gap failure.
A failure. The barrier breaks.
Yes. This is the ultimate trigger for ontological instability. When the spectral separation vanishes, the structural rigidity of the continuum is entirely lost. The mathematical barrier falls, opening what the authors term mixing channels.
Mixing channels between the smooth and the discrete.
Exactly. The previously isolated smooth relational modes, the B3 block, become degenerate with the discrete atomicizing modes, the B8 block. The system can no longer maintain a stable, continuous manifold.
So it falls apart.
It becomes highly susceptible to localized, non-linear collapse events, forcing a rapid transition into the atomic ontology.
So what does this all mean? The theoretical physics models this catastrophic transition using the mathematics of a pitchfork bifurcation. The mathematical briefing provides the normal form equation for this. F of g and mu equals 1/4 g to the 4th minus 1/2 mu g squared.
The classic normal form.
Right. How does this specific equation map onto the failure of the spectral gap in a quantum field?
The pitchfork normal form is elegant because it perfectly captures the dynamics of symmetry breaking. The variable g represents the state of the spectral gap. And mu represents a control parameter, essentially the localized stress or energy density in the continuum field.
Okay, so mu is the stress.
Right. When mu is negative, the mathematical potential has a single stable minimum at g equals 0 in the transform coordinates. This corresponds to the stable gap open phase. The continuum is smooth.
It's like a ball resting comfortably at the bottom of a U-shaped valley.
Exactly. A single stable state. However, when localized stresses increase and mu crosses the critical threshold of 0 and becomes positive, the topology of the potential fundamentally alters.
The shape of the valley changes.
Yes, the original stable minimum becomes an unstable local maximum. The system undergoes a supercritical bifurcation. The single stable path splits into two new, symmetrically lower energy stable states representing the gap-closed phase.
Literally branching like a pitchfork.
Just like a pitchfork, the continuum is violently forced off the unstable ridge and must roll down into one of these new, localized, discrete configurations. The smooth field must collapse into a particle state.
And this is where it all comes together. When that smooth continuum field is forced to bifurcate and collapse into a discrete, localized point, it has to choose a geometry for that collapse.
It must assume a shape.
Right. And this is where the genius of the author's framework comes full circle, because they bring back the exact same mathematical tool we used in the very first segment regarding fluid dynamics, spherical harmonics.
They do.
Why do the spherical harmonics reappear in the esoteric topology of quantum field bifurcations?
Because, unlike the gauge null coherence vacuum, the continuum ontology actually does possess metric structures. It has physical gradients and it has angular geometry.
It has the rules for shapes.
Yes. Therefore, when the spectral gap fails and the localized field region begins to condense into a discrete atomic state, that mathematical instability must manifest through an available angular mode.
It has to pick a spherical harmonic to collapse through.
Exactly. The system must choose a geometric shape for its ontological collapse. The mathematical models of the bifurcation demonstrate that the collapse process is a competition.
A competition between what?
Between the energetic drive of internal mixing, which is caused by the closed gap, and the system's angular stiffening.
Angular stiffening? What is that?
It's the energetic penalty required to maintain complex, asymmetric deformations during the collapse. Bending the field into complex shapes costs energy.
And nature will always favor the path of least action, the energetically cheapest route downward.
Precisely, because internal spectral mixing across the newly opened channels is energetically vastly cheaper than the high cost of supporting complex angular stiffening. The lowest available angular mode is always the first to destabilize and drive the collapse.
It takes the easiest path.
Right. And, exactly as we established with classical macroscopic cavitation, the lowest available mode is the L equals 0 spherical harmonic, the purely radial, perfectly isotropic symmetric monopole mode.
This is the absolute climax of the entire theoretical framework. When a macroscopic void in ocean water cavitates, it achieves its most violent, energy-concentrating collapse by following the L equals 0 perfectly symmetric radial mode.
Yes.
And here, at the fundamental basement of reality, when the spectral gap fails, forcing the smooth, continuous fields of spacetime to bifurcate and collapse into localized, discrete particles of matter that quantum field collects, also inherently favors the exact same L equals 0 perfectly symmetric radial mode.
It is the exact same geometry.
The macroscopic fluid dynamics of cavitation isn't just a loose analogy. The mathematical architecture governing a collapsing void in water is the exact quantum structural archetype for how the universe forms solid matter from smooth vacuum fields.
It is a profound realization of scale invariance in complex systems. The authors are explicitly concluding that macroscopic cavitation is a derived regime manifestation of a much deeper ontological truth.
So the fear of the vacuum collapsing was completely backward.
The fear of vacuum cavitation is misplaced because empty space cannot physically cavitate. Instead, the mathematics of cavitation serve as the perfect macroscopic metaphor for a closure instability. A collapsing bubble is the physical world's reflection of the deep, pre-ontological tensor mathematics that dictate how a smooth, unified continuum breaks symmetry, bifurcates, and condenses into localized, discrete reality.
It redefines everything.
Really does.
But if we pull back to the philosophical implications of this framework, this absolute redefinition of reality, what does this mean for our understanding of energy itself? Because the popular fear was always that the vacuum was hiding this catastrophic amount of stored energy, just waiting to explode.
Right. The framework requires us to completely abandon the concept of the vacuum as a pressurized reservoir of hidden energy. The violent energy releases we observe in astrophysics and particle physics, supernovae, matter-antimatter annihilation, the creation of particles in a collider, they do not originate from the pre-closure coherence vacuum imploding or releasing stored intention.
So where does the energy come from?
In this ontology, energy is not a substance stored in a void. Energy is a highly dynamic, generative process. Energy is formally defined as the measurable manifestation of a coherence gradient.
Produced during the transition.
Exactly. It is produced exclusively during rapid symmetry reduction events. When the smooth continuum undergoes a spectral gap failure and rapidly transitions down into the discrete atomic ontology, the breaking of that symmetry generates the physical flux we measure as energy.
So we do not extract energy by tapping into a deep volatile vacuum. The energy we see is the actual localized process of the vacuum's structural potential condensing into physical reality.
That is the correct interpretation. This raises an important question regarding our anthropocentric view of the physical universe.
Anthropocentric meaning our human-centered bias.
Yes. We are fundamentally conditioned by our biology and our standard models to view our highly localized, discrete, solid reality, the atomic ontology, as the fundamental default baseline of existence. We think solid matter is the bottom layer.
Because it's all we interact with.
Right? But this mathematical framework aggressively challenges that assumption. It suggests that our physical atomic universe is not the foundational baseline, but rather a highly derived, localized manifestation born from a broken symmetry.
We are living in the broken pieces.
We exist entirely within the scars of a bifurcated continuum. Every atom, every solid structure is simply the stabilized post-bifurcation aftermath of a localized spectral gap failure. The discrete universe is what happens when the smooth vacuum breaks down.
Which brings us to the ultimate synthesis for you listening right now. Anyone who has ever wondered if the universe is truly stable, why should you care about canonical sectoring, pitchfork bifurcations, and four-layer ontologies? You should care because this framework replaces the existential dread of a fragile universe with an elegant, rigorous mathematical architecture.
It brings order to the fear.
Exactly. It proves that the absolute foundation of reality, the coherence vacuum, is unshakably stable, precisely because it is purely potential. It completely lacks the physical gradients, the boundary operators, and the gauge dynamics required to implode. You cannot detonate a state of minimal differentiation.
It is logically impossible.
The universe isn't a stretched rubber band waiting to snap. It is a generative hierarchy, safely building complexity from pure invariant symmetry. You can look at the empty night sky or the incredibly complex physics of bubbles collapsing in a fluid and understand that you are seeing the exact same deep mathematical archetypes playing out safely across entirely different scales of reality.
The analysis provides a highly sophisticated comfort, I think. It replaces the anxiety of a metastable cosmos with the profound, mathematically backed realization that our localized existence is the result of a necessary, structurally rigorous, and unidirectional process of generative differentiation.
It's a one-way street to complexity.
Yes, reality is stable not by mere cosmological chance, but by the fundamental laws of pre-ontological invariance.
I could not have summarized that better. Thank you for walking through this incredibly dense tensor mathematics and ontological philosophy today. I mean, moving from Rayleigh-Plesset fluid dynamics and sonoluminescence all the way down the ladder to Omnilectic invariance and the normal form of pitchfork bifurcations, it requires a serious analytical lens. And you've made the absolute limits of reality mathematically coherent.
The pleasure was mine. The structural alignment between the macroscopic nonlinear fluid dynamics and the pre-ontological stability theorems of quantum fields represents some of the most compelling and rigorous synthesis currently being explored in theoretical physics. It's a joy to discuss.
Before we wrap up this deep dive, I want to leave you with one final provocative thought. Something to explore on your own that pushes the boundaries of the framework we've just discussed. We've traced the ontological ladder downward. From the pure, unbroken symmetry of the coherence vacuum, reality differentiated into the smooth fields of the continuum ontology. And then, driven by spectral gap failures and pitchfork bifurcations, those smooth fields collapsed into the localized, discrete matter of the atomic ontology, the reality we inhabit.
The final layer.
Right. We tend to view this discrete atomic layer as full closure, the absolute bottom of the ontological ladder. But is it mathematically required to be the end?
That is the question.
If our solid reality is simply the localized, stabilized scarring of a bifurcated continuum, and if the universe continues its trajectory of expansion, cooling, and endless differentiation, is it possible there's a fifth ontological layer waiting beneath the atomic level? A new type of hyperlocalized, fundamentally alien structural regime born from the eventual symmetry breaking and collapse of matter itself. Just something to think about the next time you look up at the seemingly stable stars or the next time you watch the violent symmetrical collapse of a cavitation bubble in your water. Thank you for joining us on this deep dive.